So we can see 3 people joined. So we can start right away without wasting much time. I believe you're hearing me. Okay, Azege can see you. So yes, can hear you. So today we'll look at collision. That is where we stopped yesterday. And like I said earlier, you need to have your textbooks close to you. Like I mentioned yesterday, there are 2 types: the elastic collision and inelastic collision. Elastic collision is a type of collision where both momentum and kinetic energy are conserved after the impact. Whereas inelastic collision is a collision whereby it's only momentum that is conserved. So, better emphasis here is always the calculation aspect of the collision. They will mention that momentum is a product of mass and its velocity. Product of mass and its velocity. So when you are talking about the collision, it means 2 objects are involved. So when you look at that, when you look at this diagram, look at section 4.5. That is where I'm trying to draw your attention. Section 4.5, as you can see here, so 2 objects are involved with, so this, the momentum before impact and the momentum after the impact. That is what we'll be looking at. So if you look at that section 4.5, where you can see this. This is the kinetic energy, which is half mv square as the kinetic energy. So the momentum It's like network is disturbing. Some people are going on and off. Network, please try and reconnect. Try and reconnect. So just like I said, that collision is classified into two: the elastic collision and inelastic collision. And in the case of elastic collision, both momentum and kinetic energy are conserved. So if you look at equation 4.9, if you look at equation 4.9, have you seen it? Where you have M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. I guess you can see equation 4.9. I hope you can see. Please, those will try and reconnect. By tomorrow's lecture, we'll try to look at the past questions. What we have done so far, based on the revision, I will try to get some past questions so that we can look at them, how we can answer those questions. So if you can see equation 4.9, that is a typical equation that describes elastic collision. A question may be put like this: which of the equation describes an elastic collision? And those options may be given. So what will normally guide you is both momentum and kinetic energy are conserved. So equation 4.9 and 4.10, if you can look at those equations, equation 4.9 stands for momentum and equation 4.10 stands for the kinetic energy. That shows that equation 4.9 shows that momentum is, equation 4.10 shows that kinetic energy is also conserved. That is a typical case of an elastic collision. So these are the things that will guide you. You can differentiate with this. You can differentiate between an elastic collision and collision. So this guide you is that for an elastic collision, both momentum and kinetic energy are conserved after the impact. And when you look at that diagram, figure 4.5, you can see it. Figure 4.5 is a diagram with a figure that describes an elastic collision. You see, before, let's look at it here. This is a figure I'm referring to in my cursor. 4.5 or 4.5. This is the figure that describes the elastic collision. M1, U1, that is for a body that has mass M1 and another body has mass sir, there was a question you solved concerning velocity time graph that you got the units of t to be 12 seconds. What's the problem with the any issue? Any issue with the question? Is there any issue? Joseph, Joseph, sir, there was a question you solved concerning velocity time graph that you got the unit of t to be 12 seconds. Is there any problem with the question? Let me know. Or are you confused about the question? If you have problem with that question, you can snap it and send it to my WhatsApp. Let me see it. Okay, you can snap it and send it on my WhatsApp so that I can see it. Okay, so let's continue. So the 1.5, which is this figure that represents the two masses m1, m2 with initial velocity u1 and u2. So this is before the collision. So after the collision, you have, the mass is constant. Still have m1. What will change is the velocity. Now you have v1 for mass m1 and v2 for mass m2. So this is a typical illustration of an elastic collision. In practice, if there's collision, energy will be converted from one form to another. So the case of an elastic collision is not always practical, because if you have maybe a collision between two cars, sometimes you hear sound, sometimes you see uh, fire and so on. So these are forms of energy. So, but here, we are saying that the elastic collision is the type that where both momentum and kinetic energy are conserved. So let's look at example 4.7, which says that a 5 kg object traveling at 1 meter per second collides head-on with a 10 kg object initially at rest. Determine the velocity of each object after the impact if the collision is elastic. This is the question. One of the objects for mass m2 is stationary. So we're asked to calculate two velocities of both m1 and m2. So we're looking for v2, v1, and v2. Is that right? So complex, but it's not. So from here we have, from the conservation law of momentum, m1 u1 plus m2 u is equal to m1 v1 plus m2 v2. That is for momentum. and mass 1 is given as 5, U1 is given as 1, that is 5 times 1 plus M2 is given as 10, and U2 is 0 because that mass M2 was stationary. That's the reason why U2 is 0. Equal to their velocity. Velocity of mass M1 is V1 plus M2, the mass is 10 times the V2. So when you look at this equation, this second term here, 10 times 0 will vanish, and you now have 5 equal to 5V1 plus 10V2. Then one will be asking, how come you now have 1 is equal to V1 plus V2? That's a very big question. But when you look at the previous line, you have 5 equal to, because that 10 times 0 will go, so it will be 5 equal to 5V1 plus 10V2. I hope you are seeing. So by the time you have this, you want to simplify this equation further. You may decide to leave it as 5 is equal to 5V1 plus 10V2. So, but to simplify further, you divide. Whatever you do to the left hand side, you must do to the right hand side. So you have 5 equal to 5V1 plus 10V2. So you can divide both sides, or can divide through by 5. So 5 by 5 is 1, equal to 5 over 5 will give you V1 plus 10V2 divided by 5 will now give us 2V2. That is where you now have equation A. That is where you have equation A. So for the kinetic, remember, for this elastic collision, we'll talk about momentum and kinetic energy. And for the momentum, we have gotten 1 V1 plus 2V2. And we term that equation A. Then the next, we look at the kinetic aspect of it. Please, do you understand why we have equation A as 1 equal to V1 plus 2V2? Do you understand equation A? I believe you are following. So I want you to respond if okay, Azuga Joseph, say yes. So if there's any other person that does not understand, you let me know so that I can explain again. So that is the momentum aspect of it, which gave us equation A. Then the kinetic aspect of it, we know that kinetic energy is half mv squared. So before the impact, we have half m1 u1 square plus half m2 u2 square equal to, after the impact, you have half m1 v1 square plus half m1 v2 square. So already we know these values. We substitute half into 5 times 1 square. Those parameters are already given, plus 10 times 0 square equal to half into 5v1 square plus 10v2 square. So when you look at this, by the time you simplify, you have half v half into 5. Remember this term, 10 times 0 square will go. 10 times 0 square will go equal to half v1 square plus 10v2 square. So we want to reduce this. So since you have half, whatever you do to the left hand side, you must do to the right hand side. So you multiply through by 2. Multiply both sides of the equation by 2 so that half. Somebody said no, sir. What is the problem? Where's the confusion? Where is the confusion? Just draw my attention where you're having issues. Where's the confusion? Akaptua Tewase. Say no, sir. What is the problem? Kaptua, what is the problem? Okay, I wait for your answer while we continue. So where you have half into 5 times 1 square plus 10 times 0 square equal to half into 5v1 square plus 10v2 square, we are going to reduce this. You multiply both by 2 so that half will go and you have 5 equal to 5v1 square plus 10v2 square. So you can divide both sides by 5 to reduce the figures. So you divide 5 by 5 is 1. That is where you have this 1 equal to 5v1 divided by 5 will now be v1 square. If you divide 10v2 square by 5 will now give us 2v2 square. That is where we now have equation B. This is where we now have equation B. So from A, if you make V1, this is a kind of symbol, and we are solving it by substitution. So you make V from equation A, you make V1 the subject. And equation A said that 1 is equal to V1 plus 2V2. So if you take 2V2, so it become minus, and V1 will be equal to 1 minus 2V2. And this is what we're now calling equation C. So if you now substitute equation C into equation B. Okay, so I did not understand the formula. Which of the formula are you talking about? Okay, let me repeat this again. Sorry, let me repeat. That is not following. So let's page. So the question, example 4.7 is what we are looking at. M1 is given as 5 kg. V1 is given as 1 meter per second square, per second rather. M2 is 10 kg and U1 is 0 because the body is stationary. That's the reason why U1 is 0. So after the impacts or the collision, the masses M1 and M2 will still remain the same. What varies is the velocity. V1 is not given, V2 is not given, and that is what we are looking for. So like I said, the momentum for an elastic collision, both momentum and kinetic energy are conserved. So we'll first of all look at the momentum aspect of it, where you have m1 u1 plus m2 u2 equal to plus m2 v2. So we'll now substitute those values. The value of m1 is 5 and the value of u1 is 1. And that's the reason why we have 5 times 1 plus the value of m2 is 10. The value of u2 is 0. That's the reason why we have times 0 equal to the value of m1 still remains 5 times v1. Remember, v1 is not known. Plus m2 still 10 times v2, which is still not known. We have two unknowns here. So by the time you simplify the equation, whatever you do to the left-hand side, you must do it to the what? Right-hand side. So we divide both sides of the equation by 5. So if you divide 5 by 5, you have 1 equal to, well, now 10 times 0 is 0. So that second term will go equal to 5v1 divided by 5 is 1. That's the reason why we now have v1 plus 10v2 divided by 5 will now have 2v2. That's what gave us equation A. So since the kinetic energy is also conserved, we also look at the kinetic energy. We know that kinetic energy generally is half mv squared. That is the formula for it. So we now have u1 square plus half m2 u2 square. This is before collision, equal to half m1 v1 square plus half m1 m2 v2 square. This is after the collision. Then we will now substitute those values. Remember, what we know here is m1 u1 m2 u2. m1 and m2 are constants. So after the impact, their value still remains the same. Remember, we don't know v1, we don't know v2. So we now substitute. That's the reason why we now have half. We now have half times 5 times 1 square plus 10 times 0 square equal to half into 5v1 square plus 10v2 square. So remember that second term is 10 times 0. That will go. So we are left with 5. I now explain why we now have 5 equal to 5v1, 10. You multiply both sides of the equation by 2, and that will reduce to 5 equal to 5v1 square plus 10v2 square. Just hold on, give me, I'm coming. Sorry, I needed to fix some things. So I was explaining that at this point, we needed to reduce where you have 5 equal to 5v1 square plus 10v2 square. Whatever you do to the left hand side, you must do to the right hand side. So if you divide both sides by 5, both sides of the equation by 5, that equation will be reduced to, that is 5 divided by 5 is 1 equal to 5v1 square divided by 5 will go give us v1 square plus 10v2 square divided by 5 will give us 2v2 square. And that is what gave us equation B. So these are equation A and B. We need to solve them, they are simultaneous equation, and we'll solve by substitution. Remember there are two ways of solving simultaneous equation, either by substitution or by elimination. So here we are solving by substitution. That is making equation 1, V1, the subject of the formula. That is from A, we now have V1 is equal to 1 minus 2V2. And that is what led to equation C. So if you now substitute equation C, into equation B, we now have 1 equal to 1, that is where you now have V1, you substitute. We now have 1 minus 2V2 all square plus 2v2 square. So we now expand this. 1 minus 2v2 square means 1 minus 2v2 times 1 minus 2v2. By the time you open the two brackets, you now have 1 minus 2v2 minus 2v2 plus 4v2 square plus 2v2 square. So if you now collect like terms, you have 6v2 square minus 4v2 equal to 0. And you factorize 2v2 into 3v2 minus 2 will give us 0. Because if you open that bracket, you still get the previous equation, which is 2v2 minus 4v2 equal to 0. So from here, we can say that 2v2 is equal to 0, or 3v2 minus 2 is equal to 0. So by the time you make v2 the subject, remember if you take this 2 to the other side, become plus, and divide both sides by 3, you now have v2 be equal to 2 over 3. So here, v2 is being 0 implies that m1 did not collide with m2, and so it is stationary. So the other one, v2 being 2 over 3 meters per second, we need to take this value and substitute in the other equation to give us minus 1 all over 3. And the negative sign shows that M1 rebounded after the impact. It bounced back after the impact. That is the implication. So this is the explanation. This is where we are. So I want us to, it's already 9 o'clock. So I want us to briefly look at the inelastic collision. Elastic collision is a type of collision where only is conserved. So if you look at section 4.5.2, that is where you have inelastic collision. And that figure 4.7 is the figure illustrating collision, where you have two bodies with mass m1, m2, u1, u2. This is before the collision. So after collision, they will stick together. The two masses will stick together and move with a common velocity. You know, in the case of inelastic, they move with different velocities. But for here, for this inelastic, they will stick and move with a common velocity. And looking at that, equation 4.11, equation 4.11 represent m1 u1 plus m2 u2 equal to m1 plus m2 v, because the two masses now have the same velocity. So if you now factorize, we now have v out. But if you open the bracket, you have m1v plus m2v. So this is the typical expression for inelastic